Hello everyone, welcome back to my channel and let's start with the simple reality today. So today is a billions of dollars are controlled entirely by the smart contracts, not by banks, not by centralized services, but by the code running on blockchain. Smart contracts power almost everything in the decentralized finance systems. They run a decentralized exchanges, lending protocols, stable coin systems, NFT marketplaces, DAO governance systems, and cross-chain bridges that moves assets between the blockchain. Protocols like Uniswap, Aave, Maker, Curve, and many others operators fully autonomous financial infrastructures. Inside these smart contracts there are unanimous pools of values. So some protocols manage hundreds and billions or even millions or even a billions dollars on assets, and all of that are the values secured by the one thing, but the correctness of code. But this creates a very unusual situations compared to the traditional software systems. In a Web 2, if a company discover vulnerability, the developer can quickly fix a code and put a push up page on that. And according to that, servers are updated, backend code is changes, the issue is fixed. But smart contracts don't work like that. Smart contracts are immutable by design. Once a contract is deployed on a blockchain like Ethereum, its code becomes extremely difficult to modify. This means if a vulnerability exists in the code, it becomes a permanent attack surface. And unlike a traditional system, smart contracts are completely transparent. Anyone in the world can read the contract code, analyze that, stimulate transactions, and try to find the ways to exploit it. This create a very adversarial environment. Developer publish the code, and attackers study that. And sometimes attackers discover the weakness before the developers do. And because of that, Web3 ecosystem has experienced some of the largest financial exploit in the history of the software systems. We have we have seen attacking involving flash loan manipulations, Oracle price manipulations, reentrancy attacks, governance takeovers, breach validated compromise, and the complex economic exploit that we are already the talk about the whole vulnerabilities in the others videos also in the detailed way. And some of these incidents insulated in the losses of hundreds of millions of dollars in a single attack. But these incidents are not just a random accidents. They reveal a deeper lessons about the how decentralized financial systems behave. Many of these exploits did not happen because of a simple coding mistake. Instead of they happen because of the complex infrastructure between the protocols, economic incentives, and the blockchain mechanisms. So, in this video, we are going to explore the security landscape of decentralized finance, and we will break down like that way the most common types of smart contract attacks, real website where you can track DeFi exploits. So you can learn from that also. Platform where security researchers practice auditing, because if you want to smart contract auditing, you have to be a good, you have to good practice on that. Like more contracts you solve or auditing, that you get a more experience. And the some kind of bug boundary programs also for the vulnerability can earn large rewards also if you can find that vulnerability, and you can get a more rewards. The tools and the tools developer use to analyze to secure smart contracts. If you are interested in the smart contract development, DeFi infrastructures, or blockchain security, understanding these vulnerabilities is essential, because in Web3, the code is not just a software, the code is the financial system itself. So, we can start with the why Web3 security matters, why Web3 security is important, so important. So to understand why smart contract security is such a big topic today, we first need to be understand the fundamental difference between the Web 2 systems and Web 3 systems. In traditional Web 2 applications, security breaches usually involves the data theft. Uh, so that companies' data, for example, like their passwords, their email address, or credit card numbers, or personal information, they can like a theft. These breaches are serious, but the system themselves usually remain operational. The company can reset the password, update infrastructures, and recover that. But in Web 3, the situation is completely the different. Smart contracts don't just manage data, they manage a real financial assets, like a money. You can be called a money. Inside a DeFi protocols, smart contracts control collateral deposits, liquidity pools, stable coins or reserves, traditional assets, and governance tokens. These contracts hold fund directly on chain. When the user deposit tokens into the lending protocol or a liquidity pool, those assets are no longer controlled by the company. They are controlled entirely by the smart contract logic. This means its vulnerability exists in the contract. The attacker don't need to hack the server. They don't need to break the encryptions. They simply interact with the protocol exactly as a smart contract allows. And if the protocol logic has weaknesses, the attacker can exploit those rules to extract the value. This one of the most important ideas in DeFi security. Many attackers are not breaking the system. They are about to using the system exactly as it is was designed, but in a ways developer did not anticipate. Another factor that makes Web3 security challenging and composability. DeFi protocols consistently interact with each other. And for example, like a lending protocol may depend on a price data from the Oracle. The Oracle may read prices from the decentralized exchange. And the exchanges may depend on the liquidity pools that they contain the tokens from the protocol. So the interconnected structures allow developers to build extremely powerful financial system, but it also create a complex dependency. If the one of the component behaves unexpectedly, the effects can cascade through the multiple protocols. This is exactly the how many DeFi exploits occur. Attackers manipulate one part of system which cause the another protocol to behave incorrectly. Like if there is something like exchange depend on liquidity pool, if they manipulate liquidity pool, then the exchanges get informations very wrong. If they something doing in the decentralized exchange, the hack or something doing that, then also the protocols are making a wrong decisions. So attacker manipulate the one part of the system which can cause another protocol behave incorrectly. And another major factor that changed the security landscape of DeFi is something called the flash loans. Flash loan allows user to borrow a massive amount of capital without a collateral. So the only requirement is that loan must be repaid in the same transactions. So now, like that means attackers can temporary control of tens and even hundreds and even $1 million in liquidity. They may manipulate the market, interact with the pools, extract the profit, all within a single blockchain transaction. Because of this, modern DeFi attackers often combine multiple techniques together, and that is also the one example. An attacker might take a flash loan and manipulate the token price, so trigger that liquidation event and withdraw asset before the transaction finish. All of that happen automatically in the one transaction. Over the past few years, we have seen many high-profile exploits that demonstrate this risk. One of the earliest and the most famous incident was the DAO hack in 2016, which is the involved the reentrancy vulnerabilities in decentralized investment fund. Later, we saw the major breaches exploit like Rohin breach hack, Wormhole breach hack, or Nomad breach hack. This incident involves vulnerability in a cross-chain infrastructures. More recently, DeFi protocols have experienced economic exploits such as Illure Finance and Mango Markets. These attacks involve manipulations of the protocol logic and market condition rather than the simple coding bugs. What of these incidents have in common in that re- they reveal how difficult it is to secure decentralized finance system. Developer build DeFi infrastructures are not just writing software. They are designing the permissionless financial system that operate in adversarial environment. Every line of code must assume that someone will attempt to break it. And This is the exactly why the demand of the smart contract auditors and the security researchers has grown so quickly. Security researchers analyze the protocol, identify the vulnerabilities, and help protect the ecosystem before attackers exploit those weaknesses. In many cases, security researchers can earn significant rewards through bug bounties programs and audit competitions. But more importantly, they play a crucial role in making a decentralized financial system safer and the resilience. So this is the part of like why this is matter. Now I think you understand why this is whole things matter the security. So there is a category of smart contract attacks. We already talk about this. There is a types of smart contract attacks. In my previous video, we explained the each of that vulnerabilities in the detail in real exploit example also, Solidity code and mitigation techniques. So if you want to understand exactly the how attacks work, how developer prevent them, then I highly recommend it that watching that video. Here I quickly show you the major categories that vulnerabilities that appear most often when auditing smart contracts and the DeFi protocol. These are the types of issues security researchers actively look for during an audit. Core smart contract vulnerabilities are these are the like I am telling the classic vulnerabilities in the directly in the smart contract. There is a reentrancy, integer overflow underflow, access control vulnerabilities, delegate misuse, unutilized uninitialized storage collision in upgradable smart contracts, signature replay attacks, self-destruct vulnerabilities, and there is like economic DeFi vectors also. The economic and DeFi attack vectors. This attack exploit economic logic of protocol. So not just only the coding mistake, but the economic logic of protocol also. So that is a flash loan attacks, oracle manipulations, liquidation manipulations, AMM price manipulations, protocol logic errors, and blockchain level surface and the other one is like blockchain level attack surface. This attack involves a blockchain execution environment. You have to remember that first vulnerability in we can found in the smart contract code. Second is the economic logic protocols and only the node code. So there is a two kind of, and the third one is blockchain execution environment vulnerability. So that is a MEV and the front running sandwich attacks, timestamp manipulations, weak randomness. These all are the blockchain levels attack surface. And the system design, and the fourth one is system design and architecture risk. These vulnerabilities come from the protocol architecture decisions, how the protocol works. This that decision that vulnerability happen. That is a cross-chain breach exploit, governance attack, upgradable smart contract risk, gas griefing attackers, denial of service attacks. So these are the all kind of vulnerabilities that happen with the smart contract code and some other parts of that protocols and blockchain education execution. Which vulnerability happen most often today? So looking at the recent DeFi exploit across the system, the most common attack vectors is today include the oracle manipulations, flash loan based on the economic attacks, breach exploits, access control mistakes, upgradable contracts, vulnerabilities. Many modern attackers actually combine several of vulnerabilities together. For example, an attacker might take a flash loan and manipulate the price oracle, trigger then after the trigger a liquidation event and extract the profit from that protocol. So that all inside in a single blockchain transaction. This whole vulnerability is combined and that is making that exploit in a single blockchain transactions. So what is the key idea? Understanding this vulnerability is the foundation of smart contract security, because when auditors review a protocol, they are consistently asking a question like, can this function is re-entered? Can prices be manipulated? Are admin permissions secure? Uh, can governance be attacked? Is the upgradable system safe? That all are the questions when we audit the contract. Then they ask from their self to code and like that way. And this is the best way to learn these patterns in by the study of real exploit happening across the system. So in the next section, we are explore website where you can track the real DeFi hacks analyze the exploit reports, and study how attackers actually break the smart contracts. So here is a part that websites where you can study and see real DeFi hacks. Now, now that we understand the different types of smart contracts vulnerability, the next important step is the learning how to study real exploits. So because the best way to understand this security is not just reading theory, it analyzing real incidents that happens in a production protocols. Where a DeFi protocol get hacked, security researchers carefully analyze that what happened. Examine they see in that like the vulnerability of smart contract happen, the attacker transactions, the economic manipulations used, and the exact weakness that allow this exploit. Fortunately, these are the several websites that document these incidents in detail. Already the whatever the exploit is happen and how that happen, that all the transactions and all the incidents they are giving in the detailed format, so the any security researchers, auditors, developers use this platform and study the attack patterns and learn from the past mistake by the other developers or user auditor or so there is a one of that is the blockthread.com or the rect news that already we see here. So the rect news, after that we see that. So first is the rect news. If you are deeply understand how DeFi exploit actually happened, rect news is the one of the most best resource available. Rect news is published detailed postmortem like a any person postmortem happen that like a any DeFi hacks also postmortem happen. Then postmortem report and the major crypto exploits are beautifully defined in the rect news. So each article typically explain the entire step-by-step incident how that happened. So for the example, rect report usually includes the timeline of the attack, how the attacker discovered this vulnerability by in the code or somewhere else, the exact technical flow in the smart contract, the amount of funds stolen, and the response from the protocol team. What are the responses happen from that team? So this report are extremely valuable because they break down the exploit in a narrative format that is easy to follow. For example, if the breach exploit occurs, the report might explain how the attackers bypassed the signature verification logic, how fake transactions were created, and how funds were withdrawn from the breach contract. Many professional security researchers read rec news regularly to understand real attack techniques used in wild. So so when you are learning smart contract security, reading this exploit report can give a much deeper understanding than just a reading vulnerability descriptions. Then the other is DeFi Llama Hex dashboard. That is also one of that. Um, so another, this is also the one of that good resources. So that is extremely useful resource of DeFi Llama Hex dashboard. DeFi Llama is widely known for the DeFi analytics platform that tracks a total lock value across the protocol. But it also maintains the detailed database of major DeFi exploit. On this page, you can see the list of the historical hacks across the entire ecosystem. For each incident, the dashboard shows the information such as the name of affected protocols, the date when the exploit occurs, the estimated financial losses, the sometimes a vulnerability category also. This gives the developers very clear picture how large the security problem actually is. For example, when you scroll through the dashboard, you might see the exploit involving see exploit involving you might see exploit involving breach vulnerabilities, Oracle manipulations, flash loan attacks, smart contract logic errors. This resources is useful to understand how frequently attack occur, and when and which sectors of DeFi are the most vulnerable. You will also notice that some of the largest losses in a crypto history came from the cross-chain breach exploit, which shows the how complex infrastructure increases this risk. The other is the Solidity, like is the name of Solidity. Solidity is other also extremely important platform of smart contract security researcher. Unlike the previous websites, this which focus on the exploit report, Solidity acts more like a vulnerability knowledge base. So it aggregates the thousand of vulnerabilities discovered during the professional security audits and the bug bounty program also they have. Security researchers can search this database to study specific vulnerability types. For example, as you can search an issue for the reentrancy vulnerability, then they shows the each entry and how many exploits they have, and according to that exploit, they all see together. And like searches by you can searches by reentrancy vulnerability, Oracle price manipulation, integer overflow bugs, and signature replay attacks, access control mistakes. That each entry typically includes the vulnerabilities description, the affected code snippets, and the recommended mitigations also. This makes a solid encryptability. This makes solid encryptability valuable for the learning how vulnerabilities actually appear in the real smart contract code base. When auditor analyze the protocol, they often reference platforms like a Solidity to compare patterns the previously discovered the issues. In many ways, Solidity acts like a search engine for the smart contract vulnerabilities. So the same of the code or protocol or something that issue already happened, then we not repeat itself. That Immunify also, the website is Immunify. It's the most important platform of the Web3 security ecosystem. Immunify is the largest bug bounty platform for the security researcher. There is a bug bounty platform, so you can, if you there is a many smart contracts are put there. If you find that whatever the bug is in that contract and what big the like how much the big that bug you can solve that, then that smart contract give you the bug bounty. If you search a bug, then you can get a bounty. That bounty is according to, I think you bounty is according to how big your bug is, how you find the big, um, how much the big of bug is. The instead of waiting for the hackers to exploit vulnerabilities, so protocols invite the security researchers to find vulnerability responsibly responsibility. So researchers analyze the protocol, smart contracts. If they discover valid vulnerability, they report it privately. And if the vulnerability is confirmed, the researcher receive that reward. This rewards is known as the bug bounties. Some of the bug bounties are Immunify are extremely large also. So in some cases, reward can exist $1 million to critical vulnerabilities, like too much critical vulnerability. If you find and if you that solve that, then you can get a $1 million also in that. Not all of that, the sum of that. Because of this, many professional security researchers are actively participate in the bug bounty program, because for that program help protocol to improve security while they rewarding a researchers of the responsible disclosure also. For developer interested in the smart contract security, platform like Immunify provide a real opportunity to practice a vulnerability research and the potentially earned rewards. So now let's see. So now let's see that all the websites that we are talking about that. Here you can say the blog thread that is a available. What are the threads happen? They are giving in the deep things. That some of the paid membership also, but some of that blogs you can see like that way. What kind of things in that happen? This like April 2026 most hacked in the blockchain, and there is a name of that all the happen hack like breaking point of ethical security, and the more detail about that you can see that in which date that is happen, that all have this all details according to that hack that is featured here. The rect news that we are talking about is like this way. There have a many are there. You can see that they have a 304 things, and the how much amount they are stolen in that hack. They're also showing like that. You can see by the research search here. You can see search here, and you can see video here. You can research on something proper, explore some any vulnerability or any name of vulnerability. So you can see here more and more detail about that. Then DeFi Olama is like this way. They have a hack, how many the protocol logic and the CL pool accounting hack, and what language that hack happened. You can see the all the details of that with here. And also we see about the Solidity. Solidity is like this way. You can hear the search Reentrancy. Then they can see that one of the hack happen. One of the contract code is there. If you like find this, you have to solve this also. How much like low filter also the low, medium, high impact, what kind of category you want to solve this. So you can see here, and you can find and start to auditing the contract from here. Here is the all descriptions, how the recommendations and all of that things happen here. Then we see about the immunify also. Immunify studio. Here we can see the bug bounty programs here. So the view bounty and the how many the you can see bounty here for this if you solve the bug, and the submit bug here, and all the code and all the things given in this. So these are the programs that we can use for the solve the any hack that is happened, and we have this all the informations here. And there is a one more I want to show you. Like this is the web3 is going great.com. They have a leaderboard, contribute, newsletter, all of that things. And they are explaining technical vulnerabilities of in that happens and all the details according to that. So like this is the interesting another interesting resources in the web3 is going great. This website is tracks major incidents across the broader crypto ecosystems. And unlike the other platforms, which is focused specifically on technical vulnerabilities, this site documented many different kinds of events also. For example, the smart contract logics, exchange hacks, protocol failure, rug pulls, and the large financial losses in the crypto project. The website organized the events in chronological timeline. So you can see there a chronological timeline, and this gives the viewer broader perspective to how security incidents have evolved over the time of the blockchain industry. So while some entries involve technical exploit, other high risk highlight the risk related to governance failures or economic design problems. Study Studying these incidents helps the developers understand the security in Web3 is not just about the code, but also about system design and intensive structure. So this all the things you can find, you can see in the bug bounty also, and you can get a more knowledge about what kind of exploit with the code and all that much you can see, and what details you find and get a more knowledge with that all the sites and all the hack that happen already. So we are going to the next section is by studying this platform like this, a developer and the security researchers can analyze the real world incidents and understand how attacker exploit weakness in the smart contract DeFi protocols. But the learning exploits reports is only the one part to becoming a security researcher. The next step is actually practicing the smart contract auditing yourself. So in the next section, we are explore the platform where developers can practice auditing smart contracts, participating in the security competitions, and even rewards or discovering vulnerabilities by its own self. Up to the point, we have talked about the smart contract vulnerabilities, how DeFi exploit happen, but understanding vulnerabilities theoretically is the one step, first step. To become a security researcher, you need to be practice auditing real smart contracts. So auditing means reviewing protocols, code base, and trying to identify the vulnerability before attackers find that. The goal of the smart contract audit is the answer like can funds be stolen from this contract? Can user manipulate protocol logic? Are admin privilege secures? Privilege is like admin, you can give the admin to more privilege that is secure to the smart contract. Are there economic exploits in the protocol design? The professional auditors spend hours and even days to analyze the smart contracts line by line and identify the potential risk. Fortunately, the several platforms where the developer can practice auditing real smart contracts and participate in the security competition also. These platforms host a real protocols that went their code reviewed by the security researcher. Let's look the most important ones here. So now we start from here. So here is the CodeVox. CodeVox is the competitive smart contract auditing platform that created by the team behind the Cypherin. You know about the Cypherin, they can also do the security auditing. So on this platform, developer practice in the audit contest. A protocol publish its smart contract code base and ask the community to review that. Participants then analyze in the contract and try to discover the vulnerability. The auditing process is usually look the something like this. Like first you download and clone the protocol smart contract repository. You start by the reading document to understand how the protocol works, and then you analyze the architecture of the systems. You try to understand the core components such as the token contract, liquidity pools, world systems, and the lending mechanism. After that, you begin reviewing the smart contract in detail. You look for the potential issues such as the reentrancy vulnerabilities, access control mistakes, or oracle manipulation opportunities, incorrect math calculation. Some of the time is many. Some of the time this is happen also, or upgradable smart contract risk. You discover the vulnerability, you submit security finding. A good finding usually includes the vulnerability descriptions, root cause of that issue, and the potential impact, and the proof of concept to demonstrate how exploit could work. So after that audit contest finish, after the audit contest finishes, judges review the all submissions. Rewards are distributed based on the severity and the quality of the findings. Critical vulnerability usually receive the highest prize and the highest reward. Platform like a CodeWorks are extremely useful because they stimulate the real workflow and professional smart contract auditors that how that work. So like if you can do the smart contract auditing and the how that work, how you can give that all things you can see here. Like you go for the we go for here and we see the price of that, and there is a contract and the submissions, the getting started, how you getting start this, the non-issue that already known that the scope. So you can see the how the contract is there, and you can view repo and download the repo and see in your VS Code and any other tool. So that is all things are there. So is the live, is the judging, what are the things are happens, reward distributed, then it's already the happen, and that all the rewards are distributed. You can find the all content, the private only, the invite only, all public, and here is you can see the ended one and already started upcoming, what is the upcoming one, that all things you can see. If you don't know about, then you can start it from here. You can see that first flights means like whatever the you want to first, you are the starting to smart contract auditing, then you start with here competitive, what is it's this, we can see that leaderboards also here. So the what kind of person, that how much earning they have, how much the findings, that all things are given here. So this is the one of kind of code hawks too. Then the other one we do see there, this is code for Rena. This is the another well-known auditing platform for the Code for Rena. And Code for Rena is also host a competitive smart contract audits, but it has own operating longer and has a large community of security researcher. The process is similar. The protocol submit the smart contract of the review, and security researchers, sometimes called wardens, analyze the code base and try to identify the vulnerabilities. During that audit contest, dozens and sometimes a hundred of researchers may review the same protocols. Each participant submit the vulnerability report. The report typically include the vulnerability code locations, explanations of that vulnerability. That is also important when you do the auditing. The attacker scenario and the mitigation recommended. After the context test ends, judges evaluate the findings. Vulnerability are categorized between the severity levels such as critical, high, medium, and low. This is the four types and levels. Rewards are then distributed among the researchers who discover the valid vulnerabilities. Some of that you can find it, but that is not valid, so you cannot get a reward. Many professional auditors actually started their careers to participating in the platforms like a Code for Rena. It's one of the best way to build experience and learn how real audit works. Then we go to finding other things, that is a heads finance. Head finance is a slightly different from the competitive audit platform. Instead of hosting time limited contest, Heads Finance provided decentralized bug bounty programs. So project deployed the bug bounty values that hold rewards for the security researcher. If someone discovered the vulnerability in a protocol, they can submit a report through the platform. The project team that reviews the report and verifies the vulnerability. If the report is valid, the researcher receive the reward from the bounty vault. The model encourage like responsible disclosure. Instead of exploit vulnerability for the profit, researcher can intensify to report issue of the product. Bug bounty platforms have helped prevent many major exploits. Sometimes researcher discover the vulnerabilities that could have caused millions of dollars in losses. So now we can understand the how smart contract auditor actually analyze the contracts. So first is like when security researchers analyze a smart contract, they usually follow the structures process. First, they study the protocol architecture. Then they ask a question like, what is the main purpose of this protocol? How do users interact with it? And where the funds is stored? So next, they review the smart contract code. They see the critical functions such as deposit, withdraw, liquidation, minting, governance sections. They took up potential vulnerabilities such as a reentrancy risk, incorrect permissions checks, unsafe external calls, and the Oracle dependency, math errors. Security researchers also analyze the edge cases of attack scenarios. For example, of like what happens if someone manipulates the price feed? What happens if user calls function repeatedly? What happens if someone uses a flash loans? By thinking like an attacker, auditor can identify the weakness before that exploits happen. So the by practicing, I talk about many. I talk many times about the practicing. So why the practicing auditing is important. Reading a vulnerability is helpful, but a real skill comes from the practicing security analyze on real protocols. Platform like CodeHawks, Code for Rena, Head Finance allows developer to gain experience analyzing complex smart contract systems. So many professional security researchers spend years participating in these platforms and the studying exploits reports. Over time, they develop intuitions of the sporting vulnerability because they are solving the many of the other smart contract before, and the skill has become extremely valuable for the DeFi system. For the DeFi system continues to grow. But auditing smart contract is just not a reading code. Security researchers also rely on specialized tools that help to analyze the contract, detect vulnerabilities, simulate attack scenarios. Like if you read by how many lines of code, and after the each of the line you find this and this. Instead of that, they are getting to use a specialized tool. In that next sections, we are exploring the most important tools used in the smart contract auditing, including the static analysis tool, fuzzing frameworks, or testing environment used by the professional auditors. Also, they are use this. So we are also seeing this kind of professional tools. So up to this point, we are talked about the vulnerabilities, real exploit platform where the security researchers audit smart contract. But one of the most effective ways to learn smart contract security through hands-on challenges. Just a reading about vulnerability is not enough. To truly understand how attackers work, you need to break down the contracts by yourself. Security researchers often practice by solving intentionally vulnerable smart contracts challenges. This platform simulate the real vulnerabilities so developer can learn how attackers exploit them. So let's look some of the most important training environment of using Web3 security community. So first is Ethernet. That one is not here, but we can see. So Ethernet is one of the most well-known smart contract security platforms. It was created for the security team of OpenZeppelin. If you know the whole smart contract, you know the OpenZeppelin what is. So the platform works like a blockchain hacking game. Each level, so we can see this Ethernet OpenZeppelin library. So each level contains a vulnerable smart contracts. Your goal is interact the contract and discover how exploit and vulnerability happen. To solve the level, you usually need to analyze the smart contract code, understand how that behaves, the craft transactions that breaks intended logics. Some of the vulnerabilities learns Ethernet include like reentrancy attacks, delicate call misuse, integer outflow, underflow, improper access control, storage manipulations, weak randomness, that all things here already have. For example, in the reentrancy challenges, the contract allow withdrawal before updating balance. You must write the malicious contract. The repeatedly calls withdrawal function to train the funds. This exercise teaching the exact mechanism behind the famous DAO hacks. So the great thing about Ethernet is forces developers to think like attackers. Instead of just reading theory, exploit you can actually exploit the contract, see the vulnerability, and happen in practice. So here you have some of the steps. You can see that all of the steps, how to deploy building and all of that. And here the all contracts are there, how to contributing in them, that all details you can, if you see and refer this, you can know the more detail about that. Then the other one is Dame Vulnerability DeFi. Here we can see the website also, how that work. Yeah, they have a challenges also here. Vulnerability DeFi is a collection of advanced security challenges focused on specifically on DeFi protocols. Unlike Ethernet, which is focused individual vulnerabilities, this platform teaches the complex DeFi exploit involving the multiple contracts and the financial logic. These contracts stimulate realistic attack scenarios that have occurred in a real DeFi protocols. Some example of flash loan, Oracle manipulation, governance taken over, liquidity pool, token approval vulnerability. In many challenges, you start with the almost no funds. Your goal is to exploit the protocol logic and the drain assets from the system. For example, one challenge may involve using the flash loan to manipulate token prices inside to a automated market maker (AMM). So another challenge might have involving gaining temporary governance voting power and the passing malicious proposal. This exercise help developers to understand how economic attacks work in decentralized finance. This is extremely valuable because many modern DeFi exploits are not simple coding bugs. They are the economic attacks involving complex protocol interactions. So the third is capture the ether. So this is a website. Is the Capture the Ether is another popular smart contract security challenge platform. It contains server hacking puzzles that teach Ethereum security concepts. The challenges covers topics such as like smart contract storage manipulations, contract ownership exploit, or cryptographic vulnerabilities, unsafe randomness. This exercise help developers understand low-level behaviors of Ethereum virtual machine. Learning this mechanism is important because many vulnerabilities occurs due to subtle EVM behaviors. So we can find this in this. So you can search on that and just see what are the things that are available in this. The other one is the Peridium CTF. So this is a website. Uh, this is the GitHub repo of the Peridium CTF. This is an advanced security competitions created by the Peridium research team. And these challenges are significantly harder or often involve complex DeFi systems. Participants must analyze a large code base and find creative exploit paths. These competitions stimulate the type of work professional security researchers perform when auditing real protocols. Many top contract auditors regularly participate in CTF competitions like this, sharpen their skill. The other one is Securum Bootcamp and the security challenges. If you go to bootcamp, you have like a open to be Discord and whatever they are announcing and details about that you can show in that. So Securum is a well-known security education initiative focused on Ethereum security. They run a boot camps and workshops that teach developers how to analyze the smart contracts. The challenge often involved identify vulnerabilities inside real exploits. Securum has helped to train many developers who later became a professional smart contract auditors. So, why these challenges are important to you also? Smart contract security is a skill that develops through the practice. When you solve these challenges, you begin to recognize common vulnerabilities patterns. Over the time, you start to notice things like unsafe external calls, missing access control checks, Oracle dependencies, upgradable proxy risk, and incorrect math calculations. These patterns are exactly what security researchers look when auditing real protocols. Many professional auditors started their journey by solving the security challenges like this, and they learn how vulnerabilities works in a practice before analyzing a real protocol. So the how developer usually approach this challenges, like that when solving the smart contract security challenges, developer usually follow the some secured structure process. First, they read the smart contracts code that try to understand its invented behaviors. Next, they analyze the critical functions that control funds or permissions. They think about the possible attack scenarios. For example, can a function be re-entered? Can a balance be manipulated? Can external contract interfere in the executions? Can the price be manipulated? And finally, they craft transactions or write exploit contracts that trigger the vulnerabilities. This process is similar to the what professional auditor do when reviewing the production protocols. Uh, so the learning smart contract security is not just about the reading documentation. It requires actively breaking vulnerabilities, contracts, and the understanding why exploit works. Platform like Ethernet, DEM vulnerable DeFi provide a safe environment where the developers can experiment with the vulnerabilities without risking real funds. By solving these challenges, developers build the intuitions needed to analyze real DeFi protocols that identify the security risk. So after these things have all of that, how you can challenges too. Then the other part is like this is the professional tools. The tools are used for the smart contract auditing. So understanding vulnerability is important, but professional smart contract auditors don't rely on the manual code review. Don't see the first like line by line code. They also specialized security tools that help to analyze smart contracts automatically. So whatever the tool available in the market, they use first that, and if that tool is also the showing some vulnerability, they solve first that, and then after they solve other vulnerabilities and check other things. So these tools to help auditors detect potential vulnerabilities, simulate attack scenarios, and How contracts behave under unexpected conditions. Smart contract security tools usually fall into the several categories: static analysis tool, the testing framework, fuzzing tools, and the formal verification systems and transaction stimulate tools. Let's go through with the most important tools that used by the professional auditors and security researchers. So the first one is a Foundry. So Foundry has like a GitHub. I will show you that also. So Foundry is one of the most powerful framework of Ethereum smart contracts and developing and the testing. It is widely used by the developer and the auditor because it provides extremely fast testing and advanced security testing capabilities. Auditor use a Foundry for the writing unit test for the smart contract, first testing contract, running invariant test, stimulate mainnet safe using mainnet forking, testing attacking scenario also. So Foundry includes the several command line tools that is we can see here. There is a command line tools of the Forge. Forge is used for the compiling and testing smart contract. Cast is used for interacting with the nodes, Ethereum nodes, and the Anvil is the local Ethereum development node. And the Chisel is the Solidity REPL. Solidity REPL for the quick experiment. Chisel. So how the process of the Foundry installing that all the process is given here. So whenever you want to creating a project, then like Forge init my project, my audit project, or like go into project and Forge build. So they compile the contract and Forge test, they run the test, all the tests you that doing in that. So security testing in the Foundry, auditors often write a first test, and that is important in that. Like they write the first is like amount zero, then the deposit amount and the withdraw amount. So the fuzzing automatically runs thousand of random inputs, detects unexpected failures. This helps identify the issue like incorrect arithmetic, state inconsistence, and unexpected edge cases. Foundry is one of the most important tools used in the modern smart contract audits. Then we showing other is a Silder. Silder also the one of the best for the smart contract audit, and that is static analysis tool that created by the security company of Trial of Beats. This tool is created by them. So the static analysis means analyzing smart contract without executing it. Silder scan the solidity code automatically and detects common vulnerability. And they said like a percentage of vulnerabilities and all this. It can detect issues such as reentrancy risk, unused return values, uninitialized variables, dangerous delicate goals, incorrect inheritance patterns, and complex code paths. Silder can analyze the entire code base within a second, and they can give you the uh, Excel no, box kind of format of how many lines of code and that all the details, what they want, what they think about the percentage of vulnerabilities and all that in the one box details. So the install Silder is pip install Silder is like pip3 install Silder analyzer, and you can run anytime in the Silder space dot, and the Silder will scan the entire contract and the generate vulnerability report. In short, in that thing, they give the report. And example output show what is a possible reentrancy in withdraw, unprotected ownership transfers, missing event emissions. That auditors can often run Silder early during the audit to quickly identify the obvious problem. So that use that and they identify that problems initial and they solve that first. Like they also like given this kind of detectors how kind of what kind of problems they detect. Here's the all information also about here. You have to visit and more detail learn about this. Anchida. So this is a property based fuzzing tool. Anchida is the property based fuzzing tool Ethereum smart contracts. So you can see this way. So instead of manually writing the test cases, Anchida is generated thousands of random transaction test current behaviors, and it is a commonly used for invariant testing. An invariant is a rule that should always remain true in the protocol. For example, total supply should never decrease incorrectly. User balance should not become negative. Deposit fund should always remain recoverable. Ancilla is repeatedly generate random inputs and the attempts to break the rules. If the invariance fails, Ancilla finds a bug. So like this, if you can see the more in detail, if you use that, then you can know about this more. So you can install by the Docker pool also and run test in that. Then is Adrian. Adrian is another static analysis tool by the Cypherin. This is made by the Cypherin. It is designed specifically for the smart contract security analysis and integrates well with the modern Solidity developments. Adrian detects issues such as reentrancy patterns, storage layout risk, and unprotected functions, dangerous external calls. Many auditors use Adrian together with a Silder and deeper analysis. Mostly the auditor not use the one tool, like they can merge whatever they like. Mostly use like a Silder and the less line, how many lines of code, how many vulnerabilities, they can go by their way to be like most vulnerable first or most least vulnerable first, or like more line first or less line first, that kind of things by them. So we can install it like with a git repo also, and here are the all functions of that, how you can install in this. So for the test you can adren space analyze space dot, so that is this will produce a detailed vulnerability report. Then the Sat- satora Satora is the formal verification platform used by the large DeFi protocols. Formal verification is different from the testing. Instead of running random tests, it mathematically proves that certain properties always hold. For example, user cannot withdraw more tokens than the deposit. Did you know that? Total supply always remain consistent and admin privilege cannot be bypassed. So Setora uses a formal logic to verify these guarantees. And major protocols like Aave, Compound, Uniswap have used this verification system like a Setora to verify critical smart contract logic. Formal verification is extremely powerful but also more complex to set up. And the additional tools are like Tenderly. So Tenderly is used to stimulate transactions and the debug contract execution. Auditor use Tenderly to stimulate exploit, analyze failed transactions, debug contract interactions. It provides a visual executions traces showing the exactly how the transactions execute. Then is Mithril. So Mithril is a symbolic execution tool for a smart contract. It analyzes the smart contract bytecode for the searchers and for vulnerabilities. It can detect issue like integer overflow, reentrancy vulnerabilities, unchecked external calls, and like that way. You can see the how that work and all the details here. Then is a Manticore. Manticore is currently that public archive repository archive by the, but you can see that and you can find similar kind of this by another also. Manticore is another symbolic execution framework developed by the trial of bits, the same of by before also. It allows to researcher to explore different executions path in the smart contracts to detect vulnerabilities. So here we are seeing about all professional auditors tools. Do not use all tools together. You can find, like, you can use the tools and you can find whatever the best for you and whatever you know the more that you in default you use more. All the tools you have to in the one go, it's not best, or you can use and you can find what is the good for you and what is the very helpful to you. So different auditors are using the different tools. So the how auditor use these tools together. So professional smart contract auditors rarely rely on the one. I don't tell you like rely on the one tool. Instead of work that combine the techniques, a technical workflow should be like read the protocol documentation. Always be you should have to be read first protocol documentation so we can know the what these protocols have to do and what are the main thing to do and what kind of vulnerabilities that happen with these protocols. With all the details, we can know better. So review contract architectures and then run static analysis using Silver or Ethereum. That is the best for the first time. Write test using Foundry. After that Silver and Adrenaline you use, you can get a in the Silver you can get a properly box kind of things that all giving the vulnerabilities and all things. Then after according to that vulnerabilities they're showing, you can do the first test, write a first test and using the Enchidna also, and stimulate attack scenario with the tenderly, and apply for formal verification using the Setora for a critical logic. And you can do whatever you like if you like to buy on self or another tools you can do. So tools that help to automate vulnerabilities detections, but human analysis is still essential. After this all the tools, that is not okay to be you are you are doing the smart contract vulnerability or you become a smart contract auditor. No, after use this tool then also we have to see the code, and so that the human analysis is essential. Many vulnerabilities involve complex economic logic, but automated tools that cannot easily detect. So the key idea is smart contract auditing is a combination of manual code review, automated analysis tools, and security testing frameworks, economic attacker analysis. So these all things you use, and the developer who want to become a smart contract auditor need to become a comfortable using these tools, also learning how to think like an attacker. This all things we can see about the audit workflow, how that you can workflow you can decide. If you want to become a smart contract auditor, the most important thing to understand is that auditing is not just about reading Solidity code. It's about understanding how decentralized systems behave under adversarial condition. A good auditor looks at a protocol and immediately starts the asking question. What assumption does this protocol rely on? What happens if this assumption break? What could economic incentive be abused? This kind of thinking takes time to develop. It's not like one to contract you can do the audit, and this things this asking the question personality you can develop. You need to strong technical foundation in a Solidity, in Ethereum, in virtual machine. You need to understand how DeFi protocols work internally, and you need to develop a security mindset where you consistently analyze how a systems might fail. Another important skill, the ability to navigate complex code base. Modern DeFi protocols can contain a dozen of contracts interacting with each other. Understanding the architecture, this system is often more important to analyze individual lines of code. But one more thing to really accelerates learning is a studying real exploit. After that you can get more and more knowledge about the code and how that happen, all the details. When you analyze how past attack happens, you start recognizing that pattern in the code, whatever you the auditing. So you begin the same categories of mistake appealing again and again in the different protocol. So if you can see, then you can remove that. And over the time, you develop an intuition to identify this weakness before they become a real exploit. Most professional auditors build the intuitions by continuously reviewing the code, participating in audit competitions, and solving security challenges. It's a process to take persistence, curiosity, and the willingness consistently learn. Because the security landscape in Web3 involves extremely fast, new DeFi primitives appears, new attack techniques appears and emerge, and the complexity of these systems continues to increase. So become a strong auditor is less about memorizing vulnerability and more about developing a deep understanding about how decentralized system works. So how that pattern and cheat sheet is here, like check the effect and all of that. So the people look the blockchain today, they often to see the hacks, the exploit, the billions of dollars lost across DeFi. But what they are really seeing in something else, they are witnessing the early stage of new financial infrastructures being built in the public. So Every smart contract deployed today becomes a part of global, permissionless financial system. A system where anyone in the world can interact with the financial protocol without intermediators. So, but with that openness comes from the difficult challenges. This system must operate in a fully adversarial environment. Every line of code can be analyzed. Every assumptions will be tested. Every vulnerabilities will eventually discovered. This is why security researchers, smart contract auditors play such an important role in this ecosystem. There are not just finding bugs; they are strengthening the foundations of decentralized finance, because the future of the blockchain is not just about the faster transactions of a new token. It's about building a system that people can trust with their money, their assets, or their eventually entire financial lives. And that trust begins with a secure code. So whether you are a developer, security researchers, or someone exploring this field for the first time, remember this: the system we are built today may become an infrastructure tomorrow, tomorrow's global economy. And the people who understand the security will be the ones who help them make future possible. Here our things are end. Here's a sum of whole of infamy. It's like some of the attacks that happens, how much amount, and learning roadmap of how you can do the better. The auditor tools like single POC is like this work, that kind of work, and beginner, that intermediate, advanced, how that they are used. Hands-on security challenges, how you can, for the beginner this use, intermediate you can use this, advanced, the common mistake of beginners, how you can not do that. And this is the our closing. So here's the our security guide of Web3 security guide is over. How you can do a become a auditor or smart contract security engineer. So you know that what are the process. So here our all topic is over. So goodbye everyone.